Okay, let's dive right into this. In the JavaScript world, it's so easy to get caught up in the hype, right? There's this default assumption that newer always means faster, that the latest thing is automatically the greatest. We see all these headlines about blazing fast new runtimes, and it's tempting to just believe them. But what happens when you pull them out of the lab and throw them into a real-world, high-pressure situation?
So that's the real question, isn't it? When you put the classic, established Node.js up against the new kids on the block like Bun and Dino, and even a multi-threaded player like Vought, who actually comes out on top when things get tough? Well, the answer is probably not what you're expecting.
Whoa, okay. This one chart pretty much tells the story at a glance. We're looking at latency here, so lower is definitely better, and I bet your eyes are going to the exact same place mine did, that huge bar on the far right. That's Bun. In this test, its average latency was literally over 10 times higher than everybody else. A result like that? Well, you just have to figure out what's going on.
So how in the world did we get a result that surprising? Well, it all comes down to the benchmark itself, which was designed to be rigorous, transparent, and something you can actually reproduce. This was not some simple Hello World test on a laptop. This was meant to simulate a real, demanding production scenario. So let's break down exactly how it was built. The whole test was built on AWS, using a proper Kubernetes cluster, network load balancers, and a totally separate machine just for hammering the servers with traffic. This architecture is key because it mimics what a real production setup looks like. It makes sure we're testing the runtime, not some other bottleneck.
And to make it a fair fight, it's the exact same code running on the same versions of Next.js and React, just on different runtimes. Everything is version locked in a Docker file. Now that is absolutely crucial, because it means anyone, and I mean you, can pull this down and reproduce these results exactly. No magic, just facts.
And the test itself? It was a beast. A constant, relentless barrage of 1,000 requests every single second for 2 solid minutes. Think about that. That's like the traffic you'd get during a huge product launch or a Black Friday flash sale. It's exactly the kind of scenario where performance under pressure really matters. And they didn't just run it once and call it a day. No way. To get reliable data, they followed a super strict protocol, a totally fresh environment for every single run. They warmed up the load balancers. They warmed up the runtimes. They even gave the system a full 8-minute cooldown between tests to make sure one didn't affect the next. And critically, they did the whole thing 3 times, mixing up the order to make sure there was no hidden bias.
All right, so that's the setup. You can see how serious this was. Now let's get back to the results, because the data paints a really clear picture. It basically sorts the runtimes into 3 very different tiers of performance.
And here they are. In that top tier, you've got Dino and Watt, just crushing it with super low average latencies, around 11 to 14 milliseconds. Then in the middle tier, you have old reliable, Node.js, sitting at a perfectly respectable 20 milliseconds. And then you have the third tier, and that's Bun, way out there with an average of 246 milliseconds. But here's the thing about averages. They can lie. Or at least, they don't tell you the full story. Averages hide the bumpy parts, the outliers. And for a real person using your app, just one super slow request can completely ruin their experience. So, is average speed really what we should be looking at?
This is where P99 latency comes in. You can think of it as the experience for the unluckiest 1% of your users, the worst case scenario. And wow, look at how the gap just explodes here. Dino, Watt, and Node are all in the 100 to 200 millisecond range for their worst cases. But Bun's P99 latency shoots up to almost a full second. You feel that. That's a delay that makes a user frustrated.
And this brings us to a really crucial idea, something that gets lost in all the talk about raw speed. In a real production system, predictable, consistent performance is often way more valuable than a high top speed that you can't actually rely on.
I mean, just look at how much the rankings jumped around between each of the 3 test runs. It's kind of wild. Dino went from 4th place all the way to 1st in the next run. Watt went from 2nd down to 4th, then back up to 1st. Performance is clearly not just one single static number, it's a moving target.
And we can actually measure this bounciness. If we look at the standard deviation, we can think of it as predictability risk. Dino and Watt were rock solid, super stable. Node.js and especially Bun had a lot more variability. And for the people running these systems, the operations team, that matters a ton. High variance means it's hard to predict resource needs, and there's a higher risk of things just slowing down unexpectedly.
So after digging through all this data, what's the big takeaway here? It is absolutely not about crowning one runtime as the winner. It's about giving you a better way to think about performance in the first place.
This quote from the original analysis really nails it. There's no magic bullet. The best tool depends completely on what you need. Are you trying to optimize for the absolute fastest average speed, the best worst-case experience for your users, or rock-solid operational predictability? They're all valid goals, but they'll lead you to different answers.
And we can't forget this number, 100%. Despite all these differences in speed and consistency, every single runtime handled every single one of the 120,000 requests without a single error. They all worked. They're all capable. The choice isn't about what works and what doesn't, it's about which set of trade-offs you are willing to accept. And maybe this is the most important point of all. This entire thing, the code, the tests, the infrastructure, it's all open source. You don't have to take my word for it, or anyone else's. You can, and you absolutely should, run it yourself. Challenge these results. Test it with your own application's workload. Find the answer that's right for you based on your own data. So ultimately, we need to stop asking which one is the fastest. That's the wrong question. The real question, the one you should be asking, is what does performance actually mean for my application, for my users, and for my team? Because in the end, the only benchmark that truly, truly matters is yours.